Hey everybody, if you're new here, my name is Jake, and today we're looking at building some security AI cameras. This is the third in an installment of these different videos, so if you haven't seen those, go check them out. So last time we were talking about this, we had some Raspberry Pi Zeros and a couple different cameras here, and then a infrared light. Now we tried all these out and they had different results. That was in the last video. Check it out, like I said, if you haven't seen it. Primarily we were using this IMX462 low light camera. One of the cameras that I didn't use in that video was this one, which is a slightly smaller 2 megapixel IMX462. Now the other one had a lux of 0.01 lux. This one has a 0.001 lux, so a little bit more sensitive to low light. Regardless, I'm not really going to be testing them in low light conditions today. Rather, I'm going to be using this camera just because it has a smaller frame. One of the things we're going to be focusing on today is kind of performance improvements over our last build. So I've ordered these POE Ethernet hats for the Raspberry Pi Zero. Unfortunately, they're pretty expensive. They're almost the price of the Raspberry Pi itself. As you can see, it's $24.99. But they extend the Raspberry Pi quite well. We get this PoE Ethernet jack. We get some USBs, and it just tightens right onto the board itself. So it's quite helpful. And now we get a faster signal because it's all running through Ethernet, and then we don't have to worry about multiple cords to run power and data. We just have one Ethernet cord, and that works great. So the next thing I wanted to do was design a case for this. This is one of the reasons this video took so long, is because I'm new to designing things and 3D printing them and things like that. So this took quite a while to figure out. So the main case for the PoE Raspberry Pi is this right here. So we have a opening for the Ethernet jack to come in, an opening for the ribbon for the camera to go out, some pads here to screw through so that this can be fastened to a wall. And then this is the lid. And then we also have the camera box. So the camera box has some posts in it so that the camera itself can be screwed in. And then a slot for the ribbon to come out, similar to the Raspberry Pi Zero box. And then this circular piece here is going to be kind of the adjustable mount that connects to the box via an M2 screw, so that I can swivel the box to the right angle. As we can see, the box has its own version of that mount on the top side. So this took a while to design because this is new stuff to me, but I think it came out pretty well. Here are the different parts, and we can see the camera is screwed in and the box has been printed out. It looks pretty decent and all installed together. Doesn't look too shabby here. And then I went outside and I just screwed it in and adjusted the camera to the frame that I wanted, and booted it up, and it worked perfect. So next we're going to take a look at the changes to the code and the software that I did. So this is the script that's running on the Zero, and I've updated it to use UDP instead of WebSockets, and that's increased its speed. This is something I mentioned last time. So yeah, we take in the host and basically create a configuration. This hasn't really changed since the last time. Really what's interesting is this section where we begin streaming over a socket, and we take in the information from the camera, and then if we have recording enabled, we want to write that to a file, and then we also want to send all of that frame data over the client socket, the UDP socket. The signal handler and the toggle event haven't really changed much since the last time we looked at this code. So this is what's running on the Raspberry Pis. So let's take a look at what's running on the host. This is the script that I'm running currently on my desktop, and it's acting as the host, communicating between the two cameras. So we load up the model, and then we access Firebase, which is going to be our cloud-based database provider. I'm going to talk about that in the next section. But moving on, we initialize a list of the cameras that we have connected. So we have our Raspberry Pi 1 and Raspberry Pi 2, and then these are the local addresses of them that are connected over Ethernet. And then we just go through that list and start listing. So obviously there's a little bit more to this code. I've just reorganized it into this Zero class. But mostly this is the same code that we had previously, except now it's working over a UDP port instead of a WebSocket. I haven't measured the speed increase with this, but it feels quite significant. So yeah, let's take a look at this. We're just gonna run the server file I just walked through, and we should see both cameras boot on. Okay, So the box with the hardware that I showed earlier is on the left side, that's RPO2. And then RPO1 is our secondary Raspberry Pi that I have connected to the larger camera that I used in the last video. So I just wanted to demo that both of them are running at the same time. So the camera on the right, the larger one, is just a nicer quality one. So you can see that the model detections are coming in a little bit cleaner. But yeah, both of these are streaming, and let's see if we can get some detections here when some people walk by. Hey, look at that. We've got some detections. It seems like the left one is struggling a little bit. Maybe I'll look at setting that up at 720p so it gets better definition. Regardless, it still gets detections, as we can see. So we can talk about storage, which is something that we didn't touch on previously. So at 720p, it's recording at about 36 megabytes per minute, and for 480p, it's recording at about 14 megabytes per minute. With the 120 gig card I have on there, that's about 47 hours of footage for the 720p and 119 at 480p, which is actually really great. Again, we're not using any of the encoding stuff that we could be using to get that number down. But still, because we're only recording when we see detections that come in the bounding box, really we should only be getting about 5 to 10 minutes of footage a day, right? With 119 hours of footage, that should last like years and years and years if we're only recording 5 or 10 minutes a day. So I think, as far as I'm concerned, the storage constraints are fantastic. So really happy with the storage constraints. Next, let's take a look at this database stuff. So I wanted to be able to stream the camera footage to my mobile device or my laptop or wherever I'm at over the internet. And I wanted to be able to do that like real time. So I decided to set up a database with Firebase, which is here. There's, again, probably better ways to do this, but in this case, I set up a simple NoSQL database. For each of my cameras, I have a config, which is just a is streaming value, which is true or false. And what this does is tells the database whether or not we should be streaming data from the cameras into the cloud database. So back in our script, I kind of mentioned I would come back to this. We have a section here that connects to the cloud database and basically listens in real time for changes to that is streaming field. So if at any time this database, for this camera specifically, is set to true, that value will get read real time by the camera, by the host machine actually. And the host machine is going to set a small flag that says, hey, we want to start recording. Later on, in the process function, when we deserialize the data that we received from the camera, we have a check here that just says, if stream to Firebase is true, which we would have gotten in real time from the database, then we want to take that deserialized data and upload it directly to our cloud database. So we have the cameras running right now, which means that if I go into Firebase and I set is streaming to true on RPO1, which I will do right now, I'm going to update it. And when I go to the streams section of my database, I can see that RPO1 is flashing orange because new data is being written to it. That's every single frame that's coming from the camera is now being uploaded here. And I'll go back to RPO1 and I'll set this to false. And we can go back here and now it's not being updated anymore. So this is how we can real-time upload data from our cameras to our database. And the nice thing about this is that we're only storing the most recent frame. So under Streams RPO1, there's only one field here, and this is the most recent frame. So I'm not storing entire videos in the cloud. I'm not storing, a list of photos. It's just the most recent photo. And so this means that, I don't have to worry about putting a bunch of my video footage in the cloud and losing access or something like that. Because it's really just the most recent photo. And if I want to do backups, I'll do physical backups of the drives that I have. So how do we use this? We have data now that's being sent into this cloud database. Well, we need to build a front end. So I built a very simplistic front end with Firebase, and I'll show you that now. Okay, so here is my sample website. Now, I'm not trying to win any awards or impress anybody since this is just a tool for me, so it's not very flashy looking. Now, nothing really shows up when we open this website up, and that's because we're not signed in. So I used Firebase to add authentication so that you had to sign in with an email and a password, or else nothing will show up. So I have to hit sign in, and then I get a prompt to log in with my email. So I'll go ahead and I'll do that. Once I'm signed in, now I can refresh and I get a little drop down list here that shows me RPO1, RPO2. So this is reading from the cloud database and telling me what cameras are available. So I'm going to go ahead and select RPO1 and then I'm going to hit the start command. And now we get our image, albeit it is a little scrunched up, so I'll do that. And so this is RPO1. I can stop the stream and then I can switch it to RPO2. And now we're getting RPO2 streamed to us. So this is pretty cool. And what I'm doing is I'm essentially just changing the database values I showed you previously. So on the config, I'm just changing, is it streaming or is it not streaming? And then when data is coming in, I'm reading that in real time and updating this photo. And again, this isn't available publicly, but if I wanted to upload this website and make it available publicly, I am protected because you need to be signed in with an email to access it. And it is set to only work with my email. So it doesn't really matter if anybody else tries to sign up or anything. It doesn't do anything unless it's my email. So this could be extended quite a bit, but I just wanted to get something working in general. I'm really happy with the work that I did on the case and the work I did with the POE and the Ethernet. I think that code and system is maturing quite a bit and the quality has come up. Unfortunately, I feel like I've introduced a couple new problems here with the way that the database is working and this little front-end website is not really the best way to do things. So it kind of feels like I'm cleaning one thing up and then I'm introducing more problems every time I do one of these videos. Maybe next time, in the next video, I'd like to train a custom model to identify mail trucks, and then I'd like it to see when the mail's dropped off at my mailbox at the end of the street there, and then send me a notification that my mail's been dropped off. So maybe we can discuss that in the next video. But that's it for me. Thanks for watching, and see you next time.